Hello everyone. I have participated in the MRTechC Information Technologies internship for embedded systems. As part of the embedded system, we have created a project called Car Black Box. Car Black Box. The topics I have learned during the internship are these. First, we have seen the basics of C programming, that is embedded C programming, and the subtopics in it are these. Next, we have seen the microcontrollers versus microprocessors and differences between them. Definition of embedded systems. We have seen the wide range of examples for different type of embedded systems and differentiated between real-time systems and embedded systems and terminology used in embedded systems. We have worked with the PIC16F877A microcontroller in this project, and we have worked with that microcontroller. We have learned types of memory and their uses. These components and basic structure and hardware are learned. We have used MPLAB XIDE and XC8 compilers to simulate the written C programming and PICSimLab for loading hex files and simulating them in PIC16F877A microcontroller. Introduction to the project. Car black box is mainly used by us in case of aeroplanes and cars to record all the events and change of gears, accidental information, event of the car, etc., and the speed you go, etc. The purpose of the black box is to record events and also known as event data recorder. These are the requirements of the project and expected output at the last of simulation of the project. This is the PICSimLab screen. This is the default screen. On the default screen, this is the time, default time, and this is the status of the car. On, event, on, this is the speed, current speed, 0. To increase the speed, we use potentiometer. See, it is increasing. To change of gears, we have kept this switch as input. Neutral gear, gear 1, gear 2, gear 3, and so on. To access the menu, we have to click the RP3. I am changing the speed, and then gears, and then to access the menu, the RP3 is dedicated. The password is 4-digit password, and if the user did not enter password for 5 seconds, it will automatically dispatch. To enter the correct password, this is the menu. To access the menu, we use RB4, clear log, change password. If you wish to clear the log, click clear log and then change password. View log. We can see the events that we have performed previously. For example, change of gear. To watch that, select that. See the events. First we have changed the speed. Next, gear neutral, speed 43. GR at speed 43. Gear 1 at 43. Gear 2 at 43. Gear 3 at 43. Speed and so on. To go back, see I am changing the speed again and change of gears, speed again and change of gear. Now we can clear log. To clear the log, you have to enter the password. View log, clear log. I am going to clear the log. Clear the log, enter. Logs cleared successfully. Now you can see that view log. There are no logs as we have cleared it successfully. This is how we created the project car black box. This is the PIC16F877A microcontroller where the code we have written will be saved. This is the project car black box. Open it. This is the view of MPLAB XIDE where we can write embedded C programming, nothing but bare metal programming. This is the place of source files where we can reach inter-integrated controller programs, ISR, main.c. In main.c, this is the program where we run. We have to include these header files. And these are the connections we have done for the PIC16F877A microcontroller. These are the place for header files. To define micros, This is for I2C module. This is for timers. And like this, we can create variable .c and .h files in this MPLAB X IDE, and we have used XC8 compiler to compile these programs. Build the project. Now build is successful. Loading is completed. This is how we can use MPLAB X IDE. I have successfully participated in every class of embedded systems internship and gained the knowledge of bare metal programming and how to use the datasheet and refer to them with respect to any microcontroller. Thanks for giving this opportunity for me, the Emag Z. Thank you, Emag Z.